All right, so this is for basically the beginner presentation, getting started with object-oriented programming with PHP. Oh, that's not going to be good. Hold on one second. Apparently an entire slide back. Sorry, bear with me. Come on. In theory, this thing has a presenter view. In reality, it doesn't. So if you're writing PHP code with procedural code and you want to learn more about object-oriented programming, this is for you. I'm going to have to look at the screen, unfortunately, because this is doing me no good. It's one bullet back from where I am. If you're just getting started with PHP, then I would say object-oriented programming is the way that you probably want to go. And so this would be important for you as well. And who am I? I'm Dave Stockton. What does that mean? Well, I run this group. The Director of Software Engineering for i3Logics, which several of you in here work for. Been programming in PHP since about 1997, and it kind of started out professionally for that as far as I was getting paid for it. As far as being a good programmer or good PHP programmer back then, I would say not so much, but as far as I know, the code that I wrote back then is still on the web, unfortunately. I've published magazine articles. And I'm going to just go ahead and switch this entire thing over to presentation mode, and hopefully that will work because it's cut off the bottom of the slide. Oh yeah, see, that's what I get to see. It's not helping me much. All right, well, we'll just go with this one. Zen Certified Engineer for PHP 5.3. I've got Brainbench certification, so that totally means I know what I'm talking about, and you should completely listen to me. No, just kidding. Well, I mean, actually, I do have some idea what I'm talking about, but, you know, you don't have to take everything as I say as, you know, gospel. Oh, this is really confusing on there. So there's my site, davidstockton.com. I very infrequently post stuff there, you know, photography, programming, Flex stuff. I also run zentutorials.com. At the moment, there's only 3 tutorials up there. And if you're interested in writing a tutorial about Zen or PHP, let me know. After I got the 3 tutorials, I've kind of run out of time to do a whole lot of stuff on it. I'm on Twitter as dstockto and furpug, but I very infrequently update there as well. So procedural code. Everybody kind of knows what this is, hopefully. It's, you know, we've got functions, PHP, and we've got a whole bunch of top to bottom programming with everything going down. You know, you start at the top of the script, you work your way down, you call some functions that are probably in some big, you know, chunky functions.php and so on. There's some problems with that though. It's very hard to reuse your code. Most of the time you're going to end up with this kind of pattern. You've got a bunch of big files with a lot of code in them, a lot of huge functions. It's very difficult to deal with. And then this is another pattern you're going to see with that, is you're going to see HTML mixed with JavaScript and CSS, and pretty much bad programming practice that you want to try and stay away from if at all possible. And actually, this is not too far off from where the Spark Relief code base is right now.
Precisely.
Not even joking. That's pretty much what it is. So.
I think there's an fnc.inc.
Yeah, it's slightly different. So instead of functions.php, it's fnc.php or fncs.php. Yeah. No, I'm not saying there's anything that, you know.
Hey, it works.
It works.
It works.
But it's very difficult to put features into. So anyway, it's fine for small stuff, which is, you know, again, how Spark Relief started out, but now they want to grow and they want to expand and they want to provide more functionality, more features, and provide help to more people. So it's very hard to build larger applications. So we're going to go over a bit of object-oriented programming terminology. First is a class. We'll also talk about methods, properties, and interfaces, and a few different object-oriented programming concepts. So we've got dynamic dispatch, inheritance, encapsulation, and polymorphism that we're going to go over. Also, there was something else after that. Open recursion. Let me see if I can get these things hooked up again. Nope. That is just fairly useless. All right, so we're going to go over what these words mean. Right after we do a brief history of object-oriented programming in PHP. So it started out with PHP 1 through 3. Rasmus said, hey, I need a thing to put a counter on a web page. And he got a thing that puts a counter on a web page. And there are basically some wrappers around different C functionality. There was no concept really of object-oriented programming. And then we have Zeev and Andre, who are now the heads over at Zen, came along and they said, hey, let's try and make this a real language of an engine and all that stuff. But it was still completely 100% procedural. There was no concept of any kind of any object-oriented programming within PHP 3. So then PHP 4 comes around and we start having some object-oriented programming concepts like class yeah, pretty much class. That's about all it had, and it didn't really do anything like hide any of the variables, or it wasn't great, but it was a start. And then we had 5, and we started to get some more object-oriented, real sorts of things, but it wasn't great until 5.2 came around, where we actually started getting our real first good PHP programming version for object-oriented programming. And now 5.3 has stuff at the bottom that I'm going to back up real quick. Oh man, this is so far off. We've got other fancy object-oriented programming that's really cool for the PHP programmers, and the problem is we go around and say, hey, guess what? We've got this new thing. It's so awesome. Our language rocks. And they're like, yeah, I've had that for 15 years. So it's awesome that we're getting these things, but we're not the first, obviously. So first off is we've got a class. So a class is basically it's a group of related objects. So you say, okay, I've got a class of things, right? Think of it like that. I want to describe how to create whatever. I want to describe how to create a shape or a car or an animal or a boat or something like that. It's a blueprint that tells you what kind of data this thing is going to have and the things that you can do to that data to get it in or out or manipulate it in some way. So literally think of it as a blueprint. There's a blueprint for a thing. I believe it's that thing in Iron Man's chest. So this is how you build a house. This is a class. It's a blueprint for a house. And we haven't said anything about it at this point other than it's a house. So here's how we're going to build a house in PHP 4. As we start doing var this, we say, okay, how many numbers of doors and how many number of windows? And there's no such concept, for those of you familiar with object-oriented programming, of things like public and private and protected, which we'll get into in a moment. It's just, here's a variable and it's on there and it's completely accessible from everything. So if I was walking down the street and I wanted to change the number of doors in your house, I'd just change the number of doors in your house, or I'd, change the door into a fishbowl or whatever I want to do, because everything's completely open and there's nothing that's hidden or inaccessible from the outside world. So we changed that a little bit in PHP 5 and beyond, where they started introducing visibility modifiers like public and private and protected. And again, we'll get into exactly what those mean here in a little bit, but they start hiding things that you shouldn't have access to, and that's a good thing. So now we're going to add some functionality into our house. So we've got a function here that's going to be open the garage door. Right now it's public, which means anybody can open our garage door, which we may want to think about changing that slightly, or building some kind of an interface or some way that we can kind of limit who gets to open our garage door. But it's a thing that you can do to a house, and this function completely controls how that happens and what goes on there. Other things we can do in the house is we can open the curtains. We can sit there and do nothing. What is a house going to do? Jump up and run away, right? So we're going to take a quick look now at the visibility modifiers, which are public, protected, and private. So public means that this thing is accessible to everything. It means any code anywhere can touch this thing. If I've marked something in a class as public, I write some other class, it can access the stuff in my class. I write stuff within my class, it can access stuff within the class. So I guess an example of that would be ring the doorbell. Anybody can come up and ring the doorbell. If I live in the house, I can go outside and I can ring my doorbell. It's all publicly accessible. Next one is protected, which means it's accessible to the class and objects that are children of that class. So this would be something like possibly turn on stove. It's only accessible if you're inside of the house, right? You can't do it from outside the house. There's kind of weak analogies, I guess, but I was trying to come up with some examples of houses and things that you can't do to them or whatever. And then something that's private, right? you can only you can only access it if you are that house or in that house, right? If I make another house that's a copy of that house, it doesn't mean I get to flush the toilet in your house, right? I only get the one that's in mine. So next we're going to talk about inheritance. So inheritance is when your rich uncle dies and leaves you a ton of cash. So it's a pretty cool feature of object-oriented. So it allows the class to take on the properties and functionality of a parent class. Whenever you have inheritance in object-oriented programming, you need to think of this as an is-a relationship, okay? And I believe I get into that. If I don't, let me know at the end and I'll come back and explain that, but I'm pretty sure it comes up. But I'm still one slide back on here, so I can't tell what's coming up. So think of it like this, right? Circle is a shape, puppy's a dog is an animal, a mansion is a house. All of these things would be potentially valid inheritance relationships. And when we translate that into PHP, we've now got class circle extends shape or class dog extends animal and so on. So we've got that relationship, and that is a relationship still holds. Some languages have a feature called multiple inheritance. This means that you can take a class and you can have it inherit from multiple things. An example of that would be I've got a person class, I've got an employee class, and I've got a manager class, right? So obviously both the employee and the manager would potentially inherit from the person class because they are a person, right? Well, the manager is also an employee, so we probably want it to have things about that. This is, now I'm thinking about it, it's not a totally good example because you can break that down into a linear relationship, but there are others, maybe you could say this is an animal, and this is an animal that flies, and this is an animal that swims, and then you've got some animal that does both flying and swimming that inherits from both sides of that. PHP doesn't do that, and they chose to do that because it leads to some problems that can be difficult to solve, and they didn't want to solve those things. So here's some examples of inheritance. So I've got a dog class, that's the parent class up on top, and it's got some functionality of extending its leg. I've also got the puppy class, which is inheriting from dog, and it has that same kind of thing, but it does it in a slightly different way. And this is when you actually do want to use inheritance, is when you want to slightly modify the functionality of the parent class. This is completely wrong. Okay, I've seen this come up a number of times. This is wrong because a dog is not a leg. Okay? So if somebody does this as an example, it's just plain wrong. If you can't take extends and replace it with is-a, you're doing it wrong. So what are properties and methods? These are the next two things we were going to talk about as far as the terminology. Properties are data about an object, things like number of doors, number of legs, type of engine, or an actual engine, things like that, things about the class or the object that you're dealing with. So if we have a circle, we've got some different information about it. We've potentially got an X position, a Y position, a radius, things like that, things that tell us about the circle that can change from one instance of a circle to another, but they're properties that are specific to that circle. Methods are things that we run against an object to change its data, to get information from it, to do things to it. So it could be things that you ask a circle. So we've got a circle, it's got a radius, we want to ask it how to get its area. We run this code, and it's going to go and look at the radius of this particular circle, and it's going to multiply by pi and raise that radius to the power of 2, and multiply that all together, and we get our area of our circle. We can also get circumference. We can do all sorts of different things on a circle. Any questions so far? I know I'm going fast. I'm at 41 out of 81. So
my question is, do you find yourself writing a lot of interfaces on the job or in applications?
Interfaces, yeah.
Really?
Yep. Yeah, they're very, very useful. And now we'll talk about interfaces. So interfaces are basically a promise or a contract of something that you can be guaranteed is going to be there and available for you to work with inside of your object or inside of your class. So why should we use them? Well, if we provide it, we know exactly what to expect, right? If I say, I've got an interface that defines a house, and it's got a door, and it's got a garage, and it's got a bathroom, and I have a house that implements, whatever that interface was that I just described, I know that that house is guaranteed to have a door and a bathroom and a garage or whatever I just said. If I don't provide those things, there's other ways to guarantee that sort of thing through inheritance, but this way allows us to specify things that we guarantee are going to be there without having to worry about, I've already inherited from something and now I need to add more stuff to it. It allows for polymorphism, which we will also get into in a moment, without requiring inheritance. So here's an interface potentially for a class of objects that are drivable. So we've got a steering function that allows us to specify a direction, and we've got an accelerate and a decelerate function. So this is kind of like, what are the base bits of functionality that I should have for anything that I would consider to be drivable? And probably this is it. Maybe there's some more things, or maybe we could argue on whether this is too much or whatever, but this is a potential interface for stuff that's drivable. So any class that implements this interface is guaranteed to have those three functions. PHP is going to complain if you don't implement one of those things, and it will not let you run it. So at that point, I don't have to know what kind of an object it is. I don't have to care, I don't have to care if it's a car or a boat or a plane. I know that this thing implements iDrivable, so I can steer it, I can accelerate it, I can decelerate it, and that's what the interface buys me. I can also have a remote control car that extends off of car but also implements iDrivable, and then it can potentially override some things about it and make it drive and steer and accelerate and decelerate in a slightly different way from how a normal car might do it. So here's a preview of polymorphism. So we've got now that we've established the car and boat and remote control car and plane and everything, we're going to create a PHP array of these objects, and we're going to do stuff with them, right? So remember I said I don't have to know what kind of thing it is. I can just take this array of vehicles, for each over them, check to see if it's an instance of iDrivable, and if it is, I can go and have it steer in drive in a circle. So we're doing NASCAR boating and NASCAR planing, and everything else we want to do is we go left and then straight and left and straight again. And it doesn't matter. My code doesn't care if I'm flying NASCAR plane or any of that. So the next part is dynamic dispatch. So now we're in the object-oriented concepts part, I believe. Yeah. Yes, we are. All right. So it means that the object is going to determine what it's going to call at runtime. So it doesn't know when you're writing the code necessarily what's going to happen. And what that means is, let's say we have a class for a base salary, and we say, okay, this base salary has a get pay. In this case, I'm implementing the iPayable, which we can imagine says you must implement this function called get pay. And the idea behind get pay is it gives you some kind of a multiplier of your salary, right? So we have base salary and we have bonus pay, and you can see that they do slightly different things, right? So when I have my employee, I want to get his salary. Now I take a look at his review. If his review is excellent, then he gets the payout using the bonus pay piece. Let me see if I can mouse over there. He gets bonus pay right here, right? So he's going to get a higher payout if he's got an excellent review than if he's got some other kind of a review. But I don't know what he's going to do or what kind of a review he has at the time that I wrote the program, right? I may be pulling this employee out of a database, maybe some other information is putting this in, and I won't know until runtime which one of these things I'm going to do. But when I call get pay on this payout here, everything's going to work fine. It's going to call the proper object. What's that?
Missing your parentheses. You have a class, bonus pay is base salary.
What?
Missing your parentheses.
No, I'm not. Doesn't take any parameters, it doesn't need it. You're talking about right here and here?
Yep.
Yeah. No, they're completely optional if you're not passing parameters.
5 and 7.
What? I have a PHP 5.3 certification, so I know exactly what I'm talking about. So anyway, basically what I just said, at compile time or at programming time, we didn't know which one we were going to call. We didn't know it until we figured out what the employee's review was. So the next concept is encapsulation, which I touched on a little bit ago. And encapsulation is basically restricting access to who has visibility or who is able to access or run or do stuff with whatever it happens to be. You know, who has access to, say, change the number of doors in your house or open the garage door or flush the toilet in the house. And it's a good thing. Now, say, well, why would I want to restrict access? I want access to everything, right? Well, not really, right? Imagine if you're trying to drive your car, and in order to drive your car, you had to actually manipulate the engine to do things. You had to pull on the throttle cable, or actually you had to reach in there and pull the little thing that, you know, whatever the throttle cable does, right? Or you had to, you know, do all of these things. And we have, you know, interface in another way that kind of abstracts that out. And that's a good thing, right? That everybody can drive their car. Well, not everybody can drive their car, but most people can drive their car, but none of them have to know how the engine works in order to be able to drive the car. So we hide all of that thing to the interface that's exposed to the driver, the steering wheel, the gas pedal, the ignition, things like that. And as you go deeper in, or you peel away layers of distraction, then you can get into, okay, I've got this many cylinders, or I need this kind of fuel, or I need a fuel injector or a carburetor or whatever. But all of those things are encapsulated, and you can think about all sorts of real-world objects that have encapsulation. So we don't necessarily want to have direct access to everything and all the stuff that we deal with. It would be, for one, it would be overwhelming, and two, we'd probably screw it all up. So, yeah, that's what I said. So what this means also is if I want to change something out, right? I want to upgrade my engine to a better engine or something like that. I don't have to relearn how to drive a car. I don't have to change my steering wheel and my pedals and everything else because they're separated out. The car hides this information from me. And so that's encapsulation. And I can change out all these various parts without having to mess with how I interface with the car. And as a programmer, you can change out how everything works behind the scenes on the website, and people don't have to relearn how to deal with your website, or they don't have to go and learn a new program. But we can upgrade things. Somebody's messing with the Spark Relief Dropbox. So when you look at good object-oriented programming, it allows you to do these sorts of things. We should be able to treat a class as something that's replaceable by another class as long as it's implementing that interface or providing that same kind of functionality. It can do things in a different way, right? So if I've got code that I use to, say, sort a list of numbers, I don't really care if it's, other than speed-wise, I don't care if it's bubble sort or quick sort or merge sort or whatever else. I can switch those out and my results are going to be more or less the same. I'm going to get a sorted thing out of the other side. I might get it faster in one way than the other, but if we started out and said, okay, we got to sort this stuff, and we said, I don't know how to do this, I'm going to do a bubble sort, right? Everybody know bubble sort? Not recommended. It's only better than, say, random sort, but also very not recommended. Later on, when we learn these new things, we can put those in place, and the rest of our code didn't have to change, right? So that's a good thing. Another thing that allows you to do is kind of limit the possible values that you can do or the possible interactions that you have. So if I want to say, all right, houses can only have at most one garage, right? That's kind of a ridiculous example, but if I wanted to make a house that could only have one garage, I can go in there and say, okay, you can have 0 garages or you can have 1 garage. And if I say, I want to set this garage, I want to set 4 garages, we can have the class disallow that sort of action, right? If we had direct access to the number of garages, then I could have 4 garages if I wanted to. And that's not necessarily a good thing because I'd probably be in violation of my homeowners association or something. So it really helps you keep things working in the way that you want them to work, right? Limit them to valid values and your code works better usually. So here's an encapsulated dog, right? We've got some legs in the dog function, and we allow you to set the legs as long as it's an instance of iWalkable, right? And pretend that iWalkable has stop and go or something like that. And we go and add all of these legs. So at this point, I can go and pass in an array of garbage and say, set this to it. And unless some of the garbage in there is walkable, it's going to ignore it, right? It's not going to set, my dog's legs to garbage. Does that make sense? So we ensure that whatever we're doing, whatever we're sending in, will still allow the dog to work, right? It might have to, walk funny if it's got, walking garbage legs or whatever, but we know it can still walk. We know that it's still got whatever iWalkable says it should have. So if we had non-encapsulated legs, oh, that's a bummer. It's going to leave out the bottom part of that. And we said, all right, we've got public legs. They're publicly accessible. Anybody can do whatever they want with them. And then we're going to walk by looping over the legs and telling the legs to walk. And I create a new dog. Let's see what's at the bottom.
Can you go full screen?
What's that?
Can't you go full screen?
When I go full screen, it puts it over here and it blanks out this one. Yeah.
Can you auto hide your tool?
Mirror displays.
Shrink the font.
What's that?
Mirror displays.
I might be able to. Yeah, you know what? Yeah, bear with me a second. I'm going to back up and I'm going to switch to non-presenter mode, and then I should be able to do this. This is what I'm seeing. Notice it's like 3 slides ago. Raise. All right, that should show much better. Now I'm looking at the same thing that you guys are seeing, I think. All right, here we go, back to where we were. So now we've got Fido. We create a new dog, and then he's got public legs, so we set it to guacamole dip, which is, he's going to have a hard time getting around. So next step is next concept is polymorphism. So this allows us to use an object even if we don't know what it is at the time we're writing the code. If it conforms to a particular interface or it's got the functions that we need, we can use it, and we don't have to know what kind of a thing it is at the time we run it. So if I've got a dog that extends animal, and it's got a speak function, it says woof. I've got a cat animal, it has a speak function, it says meow. I can now create an array of cats and dogs and tell them to speak, and I'm going to get the proper output according to what object I happen to be dealing with at that time. So in this case, I've got this play with animal function. Tells the animal to speak. I'm going to loop over it, tell it to play with the animal, and I'm going to get back out, woof if it's a dog, and I'll get meow out if it's a cat. The next concept with object-oriented programming is open recursion, and it allows the object's methods to call themselves and perform recursion within an object. Everybody familiar with recursion? Yeah? Okay. So here I've got a Fibonacci class. This is, again, not a great example of stuff to do with recursion. But by providing this keyword here, it tells me within this class, I want to do this function call, right? So this would allow me to say, create a bunch of Fibonacci classes and run them, a step at a time or whatever, and they would all be keeping track of where they were in the Fibonacci recursion on their own, without, messing with each other. So where do you go from here? Well, we've got other concepts to look at. Static. We've got design patterns. Design patterns have been around for a good long while. If you think that they came around with Gang of 4 in 1994 or 5, whenever that book came out, they've actually been around way, way longer than that, and were applied to all sorts of things that are not even programming related. There's also inversion of control, an example of which is dependency injection. That's another good thing to look at. And you've got abstract classes. And I think I probably got through here in, it's not too bad, about 7 minutes early, which leaves a little bit of time for questions. So, any questions?
In one of your interface examples, you had a remote control car extends car, and your car implemented the interface.
Right, I wouldn't even have to specify the implement part. I wouldn't have to specify that I implemented the, correct. But I can still go and overwrite it, and I believe I can specify it without any problem, but I wouldn't have to. So he was saying back on, let's see. Oh, come on. You're saying right here, right? Yeah, so this part implements iDrivable. It's automatically implementing iDrivable by the fact that it extended car, which already implemented iDrivable. So you would not need to have implements iDrivable.
So you probably would need to override those either because you
I wouldn't have to, but I'm assuming a remote control car drives somewhat differently than a regular car. But yes, you could.
You wouldn't have to implement the iDrivable or override it. You would just override it.
Correct. Yep.
So, with that in mind, if by default you get the implementation of whatever you're extending,
Yep.
if you were to implement something else, does iDrivable still exist, or does it
Yes.
just add to the implementations?
It still exists.
So it just adds to your implementations. There's no way to take away an implementation.
Right. If you've extended something that implements something, whatever you extend, or whatever is the extending thing, also by definition implements that thing as well. And if you do an instance of check on any of those things on remote control car or car with iDrivable, they'll both be iDrivable. They'll both be car.
What about multiple implementations?
So that's one of another reason to use interfaces is that you can implement multiple interfaces. You cannot extend multiple classes within PHP. So if I need to know that this thing is drivable and maybe you can remote controllable, I can implement both of those interfaces, and then I can use the remote control car in the places where I need stuff that's remotely controllable, and I can use the drivable stuff in the places where I need stuff that's drivable. Any other questions?
Yeah, we said where to go slide, like our food questions.
Uh-huh.
Put that back out.
Yep. Maybe.
Do you want to talk about when it's appropriate to use a static class as opposed to object-oriented class?
Sure.
Keep doing that, and I'll just
Is that where you want to go?
Yeah,
I'll
that's
take a
exactly
picture
right.
real quick.
This one?
Yeah.
Okay. And what was your question?
Just when it's appropriate to use static class.
To when it's appropriate to use static methods within a class?
Call static classes instead of implementing instances of objects.
So it's a lot of the stuff's somewhat debatable, right? Static stuff is harder to test. But if you've got functions that don't require things on the object, if in other words they're not using this, you're adding two numbers together, it doesn't require you to do anything with anything that's on the object. You can put statics on there, and that's appropriate depending on whatever your coding standards might be or whatever.
You can use static when you need a singleton type of pattern.
Yeah, you can use static when you use a singleton type of pattern, where you want, basically anytime that if you've got a method on a class and it doesn't have this in there, probably doesn't need to be a class method. It could be a static class method, but it doesn't need to be a normal one. You have any thoughts on it, Will, or?
I can barely hear from back here.
You can barely hear? So when is it appropriate to use static functions in a class?
Static function in a class? Well, it really depends. So you might have a static class if you have absolutely no state. So it's better to use a class if you got a class with state, instantiate that, because you're going to pass that around and it's going to have sort of a life cycle. So you're going to instantiate an instance of that, talk to different properties. It's going to kind of hold state. You're going to do things with it. Methods that you call are going to interact with properties that you've set, things like that. So that's when you know that you're going to have sort of an instance type object versus static. Static is something that you want to use when you know that you want to put in some parameters on a method and get the exact same thing back every single time, no matter what.
So, kind of same view, I guess. Make sense?
Yeah, totally.
Cool. Any other questions? Okay. So we're a little bit, actually pretty much right close to on time. So we'll go ahead and have about a 10-minute break. If you need the restroom, it's right out the front door. If you need more burritos or beer or diet soda, they're around. And then we'll do the prize drawing when you guys get back in 10 minutes. And then will present after that. Thanks.
I only asked that question because a lot of people have different opinions, and I just